So let's go to chapter 41, scientific notation. So for this, basically, you can use, again, this is kind of like the logs chapter where a lot of this, if you're just good with a calculator, you don't even have to like learn it. So just know that you can do that instead, because the ACT, you get a calculator the whole time. But if you want to just like learn really quick the rules without a calculator, or maybe you don't trust calculators, what you would do is basically whenever you're dividing with scientific notation, you just divide the parts. So it would be like the 2.16 divided by 3 times whatever these were divided, and you would just use quotient rule there. And then for stuff like, let's see, like expressing it as decimal, again, like just put it in your calculator. But if you don't want to do that, like you could just say that this is how many spaces, how many decimal places you're moving left and right. And then for like, if you're turning it the other way into like scientific notation, it would basically be just make sure like 10 to some power gets you back to this number. And for scientific notation, you're going to want to have it be like it has to be that the number here, like the 7 in this case, has to be a digit between 1 and 9. And it can't be like 15.2 or something like that. You can't have 2 digits right there. Just has to be 1 digit right there, between 1 and 9. So then, if the exponent is, so people always say this rule of like, if it's negative exponent, do I go left or right? I don't like to teach that rule because, you can mess it up when you start doing different types of problems. So what I like to say is if you're multiplying by something that's to a positive exponent, like let's just say an easy example, like 5 times 10 to the 8th power, your number is getting bigger. So you should think that your decimal's moving to the right in this context. Now, if you have, for instance, 5 times 10 to the negative 2, if it's a negative exponent, that means that your number is getting smaller. So you're going to move the decimal to the left. So think about it like that. Because when you start having to compensate, like we'll see on number 1 is an example of this, it gets a little tricky with like the left and the right thing to kind of remember. So I would just like kind of use logic more so in this way. So then let's go to number 1. So number 1 says we have this right here. So remember when you're dividing between these, we have to divide this part first. So we would do 2.16 divided by 3, and that's going to be 0.72. And then we do times whatever this part is right here. So right there, we have the same base, 10. So then we have the same base, so we use quotient rule. So we would say negative 22 minus 11 is going to be negative 33. Now, here's where like the left and right stuff usually like gets people. This is one of the instances. So here, you'll notice that we have 0.72. And like 7.2 all over here is the options because they're writing it in scientific notation. So we have to think, how can we change this to look like the answer choices? We have to move this over to make it 7.2, but you can't just magically do that and not do anything to the right side of the problem. So with the 10, you have to ask yourself, okay, how am I compensating for this? So this would become negative 34 because if you move the decimal this way, in order to get back to the number you had, you have to get, you have to say like, I'm getting, I'm trying to think of like the best way to phrase this. So if you are making this into a bigger number right here, you have to compensate by making the other one smaller is kind of like how you can think about it. I think that's like the easiest way to phrase it for people. And that's why I say don't do the left and the right thing because you can kind of get mixed up with that when you start doing problems like these. So negative 33 I got by using the quotient rule, which says if you have like bases, you subtract the exponents. So negative 22 minus 11. And then someone said, how'd you get 0.72 without a calculator? I'm using a calculator right now because this is the ACT exam. But if you want a review of how to divide with decimals, you can go to my YouTube channel. There's on the Overcoming SAT Math playlist. If you go down, like it's like 3 or 4 videos, the one that says the 3 reviews has like a bunch of those types of problems that'll show you how to review that. So then that's what we got for the answer. So it's going to be A. So let's go to number 2. 4.3 times 10 to the negative 7 expressed as a decimal. So again, if you have a negative exponent, that means that this has to get smaller. So we move the decimal to the left if we want it to get smaller. So we would move it to the left by this many, which would be 7. So move it to the left by 7. That means you have to add 6 zeros in front. 6. And then it would be 4, 3. And you can even like check, like do the bunny hops if you want. Like, is this 7 spaces that I went? Like, if you are just like really not like good at this type of stuff, you can just kind of like check yourself. Did you go 7 whole spaces? And you did. So then this is the number that it has to be, which would be 1, 2, 3, 4, 5, 6. Okay, so G. What's my YouTube name? It's the same as this account, AG Tutoring, and if you have trouble finding it, it's linked in my profile. This is ACT Right. Yes, and it's not, for people asking about specific grade levels, it's not specific to any one grade level. It's just basically like testing on all the math before calculus. Okay, and thanks for the likes, guys. Please share this with anybody that's doing SAT or ACT prep. Right now we're doing ACT. So let's go to number 3. The product of 3,240,000 and 1,500,000 is equal to. So let's see. We're going to turn these each into scientific notation. So remember, to turn this 3 million thing into scientific notation, you have to put a decimal point right after the 3 because you want whatever is right here to be 1 digit between 1 and 9. So that means that the decimal has to go there for that to happen. And you could just drop the zeros afterwards. And then that's times, and then you have to say, okay, what do I have to raise this to so that I could get back to that if I wanted to multiply this all out? Well, to get the decimal from here to over here, where it originally was, how many spaces is that? That would be 1, 2, 3, 4, 5, 6 spaces. And it's getting bigger from here, so it has to be a positive. So now we're going to say, okay, how do I turn this into scientific notation? Well, again, I want 1 digit to be right before the decimal place right there, between 1 and 9, so that decimal has to go right there. And now ask yourself, okay, this I have to multiply by 10 to some power to get back to here, this number right here. So my decimal is right here currently. So then if I look at how many bunny hops that is, that would be 6 bunny hops as well. And then you have to ask yourself, okay, this number, to get from this number to this number, am I getting bigger or smaller? I'm getting bigger, so that means that I have to have a positive exponent for my 10. So this has to be positive 6. Now, this is similar to the division rules up here, where like you pair them off, where like the numbers pair off when you multiply, and then the tens pair off when you multiply. So it would be 3.24 times 1.5, and that's going to be 4.86 times 10 to the, and now the tens pair off, so 10 to the 6 times 10 to the 6, that would have the same base of 10, and then you add the exponent. 6 plus 6 is 12. So then it would be 4.86 times 10 to the 12. So then let's go to number 4. Hold on really quick, my neck is killing me. Let me just crack my back a little bit. Okay, so let's go to number 4. So it says, we have this right here. It's closest to which of the following values? So for this one, it's kind of like distributive property, but I don't want to use that word because it's not necessarily that. And it's basically like the 5 goes to each of these inside. So like you say 1.7 to the 5th power times 10, 10, and then the 5 gets multiplied by the 12. So like you multiply basically the exponents by what's on the outside. So 1.7 technically has an invisible exponent of 1, so 1 times 5 is just 5, so 1.7 to the 5th, times, and then it's going to be 10, and then multiply the exponents here. 12 times 5 is going to be 60. So then we have right here, you would just do 1.7 to the 5th power in your calculator, and then that's going to be 14.19857 times 10 to the 60th power. Now remember, for scientific notation, we want to make sure that the decimal, there's only 1 digit between 1 and 9 to the left of the decimal. Right now we have 2. So we need to move this over here so that it goes after the 1. So then it's 1.4, and then they rounded it, so that's why it says closest. So 1.42 would be how it was rounded. Because if you are at 1 and you look at the neighbor, it's 5 and above, so that goes up to 2. And then that's times 10 to the, remember, when you move the decimal, you have to compensate with the exponent right here. So the exponent right here was 60 before we moved everything. Now, after you move it, it would be 61 because you have to think, okay, I want to get back to what I had before. To get back to that, I have to get larger because I have to move the decimal to the right. When the decimal moves to the right, the number gets larger. So I have to compensate by going up by 1. So that's how I got 61. So then let's go to, someone asked, why are you multiplying them separately? That's just how scientific notation works. Like, you don't have to like keep multiplying everything out. It's just written in scientific notation. So like you wouldn't have to do times 10 to the 61 like in your calculator. It's just how we write it. We instead decide to write 10 to the 61st power. This is for multiple grade levels. There's not any specific grade level for this. Would it not be 59? No, because you have to think, okay, to get back to what I had, I would have to get larger by moving the decimal place 1 to the right. So that's also like why I don't like to think in terms of left and right, because the rules can get tricky when you're compensating, when you're doing the compensating thing with exponents. Think about like, how do I get back to that original thing? Do I need to get bigger or smaller? And that determines if you need to go up or down in your exponent. So then let's go to number 5. Which of the following shows this expressed in scientific notation? Remember, scientific notation means that you need to have 1 digit to the left of the decimal point between 1 and 9. So that means that my decimal has to move here, because then I'll have a 2 there, and it's 2.07. But I can't just do that without compensating with times 10 to the something. So then to move from there to here, I had to go 1, 2, 3, 4, 5 bunny hops. So it's 5 bunny hops. So I know my exponent has to be some version of 5. It could be -5 or +5. So I know it's -5 because remember, when I multiply this all out, I should get back to this original number. This is the same thing. These are equivalent. It's just being written in a different format. So I need to make sure whatever I do here gets me back to that original number. If I'm going back to that original number, this has to get smaller. I have to move the decimal to the left is how you can think about it if you're thinking left and right. This number has to get smaller to get back to where it was, so it has to have a negative exponent to do that. So people are still confused about the 61, so I had to move the decimal right here over 1 to make this into 1.42, so I had to compensate by adding 1 to the exponent over here. For how many decimal places you move, you either have to subtract or add that many to your exponent. In this case, we were adding 1 because to get back to this value, you have to get bigger. So then let's go to number 6, or sorry, I didn't even put which one it is, so that would be C. So then for number 6, it's going to be that we have this times that. So let's turn this number into scientific notation. So to turn that into scientific notation, we're going to put a decimal point right here, and it's going to become 3.52 times 10 to the some power. Now our decimal moved from over here, 1, 2, 3, 4, 5, 6 bunny hops to get over here. So the exponent here has to be 6 or -6. Now I'm going to decide, does it have to be positive or negative? Well, it has to be positive because to get back to this original number, when I'm multiplying by 10 to some power, it has to get bigger. So it would have to be a positive exponent. If I have to get bigger to get back to this original number, I have to have a positive exponent. If I have to get smaller, then I need a negative exponent, basically, is another way to think about it. So then that's going to be that number in scientific notation, and we're finding the product of that and the other scientific notation thing. Well, technically it's not in scientific notation, but close enough. So it would be 0.56 times 10 to the -8. You can decide to like move the decimal over and compensate if you want to, but you don't necessarily have to do that here. You, if it's written as like times decimals times 10 to the some power, you can just go ahead and do the pairing off with multiplication thing, where you pair off 3.52 times 0.56, multiply those, and then multiply the tens to get your answer, and then you can convert it at the end if necessary. And thank you for the roses to the person that sent that. So then let's do that. We're multiplying, so we do 3.52 times 0.56, and that's going to be 1.9712 times, and now you pair off the tens and multiply. So 10, and that's 6 and negative 8, and so we have the same bases and we're multiplying, so we have to add the exponent, so that would be negative 2, 10 to the negative 2 power. And then if we look at our answer choices, it's going to be K. At what age do people take tests like this? So you can take this at, like, there's adults that take these exams too. Like, a lot of tutors will, like, use it on their resume of, like, going to get, like, a perfect score. I think that's a waste of a weekend. And I already got a 34 when I took it in high school, so I don't do that. But they're like, you can take it whenever. But people typically take this in high school, usually around junior year. So then, give me 1 second to get water really quick. So let's go to number 7. It says, which of the following is equal to this and is expressed as a decimal? So remember, if you have a positive exponent, that, like, you're multiplying by 10 to a positive exponent, that means that this number has to get bigger, and the way we have to move the decimal is to the right, because that's the only way it would get bigger. If we're moving to the left, it would get smaller. So we have to move this to the right by 8. So do 8 bunny hops to the right. So if you want to, like, see it out, 1, 2, 3, 4, 5, 6, 7, 8 bunny hops, and fill the empty spaces with zeros. So it's moving the decimal all the way over here now, so we're getting rid of the decimal right there. So then it's going to be 930 million, which would be D. Say yes, queen, for me to solve a problem. What? Okay. So let's go to the next one, number 8. So this is division in between these. So remember, when it's division or multiplication, just pair off the decimal parts and pair off the 10 parts. So 2.4 divided by 3.2 is what you would do first. And that's going to be 0.75. And then now pair off the 10s. So now 10 to the negative 4th divided by 10 to the negative, or 10 to the second power, sorry. So this would be quotient rule, so it's going to be 10 to the negative 4 minus 2, which is going to be negative 6. So then, let's see, now we just have to move the decimal place so that there's one digit before the decimal to the left. That's between 1 and 9, so that means we would have to move the decimal over to here after the 7. So it'd be 7.5 times 10, and then you would say to the negative 6, you now have to compensate because you moved the decimal over. So then you would have to say, okay, this becomes negative 7, because to get back to that that number, I would have to move the decimal to the left. I would have to get lesser by one space, one bunny hop, one space that I moved, however you think about it. So it would have to be minus 1, which negative 6 minus 1 is negative 7. So it would be F. So then let's go to the next one, number 9. So number 9 says 8% of this one. It's not G, because you can't just magically move the decimal for the decimal part and not change how this exponent is working, because then you're getting a completely different number. The whole point is that these are equal to each other. So in order for this to be equal, you have to change both numbers to compensate for how you move the decimal. So let's go to number 9. Number 9 says 8% of all of that is equal to, so remember, percent we write as a decimal by moving the decimal place 2 to the left. So it would be 0.08 times 1.14 times 10 to the 5th. Now, let's rewrite 0.08 in scientific notation. Well, we can move the decimal 2 to the right, and that would be 8 times, and that would be 10 to the negative 2nd, because remember, these have to be equal to each other. So for 8 to get back to 0.08, it has to get smaller, so the exponent has to be negative. So now we're going to multiply that by the other thing that we'll just copy over, which is already in scientific notation. And then we're going to pair off the decimal parts and multiply. So 8 times 1.14 is going to be 9.12. And now let's pair off the tens and multiply those. So 10 to the negative 2nd times 10 to the 5th, you would add the exponents and keep the like base. So it's going to be 10 to the 3rd power. So in the answer choices, they can also give it to you in terms of like regular numbers where you have to turn this into a regular number. That would just be like doing regular multiplication. You could plug this into your calculator, or you could say, I'm going to move the decimal this many to the right. Or you could do the whole multiplication out and say 10 to the third is equal to 1,000. 1,000 times 9.12. Whichever way, there's multiple ways to do this. I'm going to just do the way where you move it 3 to the right to make it bigger, and that's going to have a 0 added in that blank space, and that's going to be C, 9,120. So now let's go to number 10. It says, Olivia went to visit the Colosseum in Rome with her friend. Her friend told her that the Colosseum was built with 300,000 stones. The number of stones written in scientific notation is, and then we just basically have to write this number in scientific notation. So remember, for scientific notation, you have to have one digit to the left of the decimal between 1 and 9, so the decimal has to go there. So we need to have 3.0 times 10 to some power. And remember, these are equal. We're just writing it a different way, but we still need these to equal the same number. So we have to ask ourselves, 3 times 10 to what power gives us 300,000? So you can like kind of just like multiply it if you're really bad about the like what number goes exactly there, or you can think how many spaces does it move, that sort of thing. That's kind of easier for me, so that's what I'm going to do. So I'm going to say to get from here to there, I had to bunny hop 1, 2, 3, 4, 5 spaces. And so if I'm going from 3 and I want to make sure that it gets to 300,000, I'm getting bigger. So I would have to have a positive number as my exponent, so it's positive 5. So then it would be F.